report. The floor is yours. Group number one, do not forget to post your slides dito sa Google Stream na to.
Okay, sir.
Good morning, everyone, and welcome to our presentation on the different process scheduling algorithms. So, we are the group 2, and today we will be discussing the different algorithms used by operating systems to manage the execution of processes on a computer system. So, process scheduling is a critical component of any operating system as it determines how and when processes are executed on the CPU. It is important for the operating system to manage the execution of processes efficiently in order to maximize the system's resources and to ensure that all processes are executed in a timely manner. There are many different process scheduling algorithms that have been developed over the years, each with its own strengths and weaknesses. So some algorithms prioritize short jobs while others prioritize jobs with higher CPU utilization. Some algorithms are more complex and they take into account factors such as process priority and aging. So throughout our presentation, we will be exploring the various process scheduling algorithms, discussing their advantages and disadvantages, and examining how they are implemented in modern operating systems. So, an operating system connects computer hardware to users and facilitates interactions between various applications and hardware. So, Um, it includes the memory, file, and process management. So scheduling algorithms in OS or operating system prioritize the execution of processes according to a set of rules or guidelines, optimizing resource utilization and ensuring timely execution. These algorithms help the CPU prioritize processes according to a schedule while keeping others on standby, ensuring that each process gets the necessary resources to execute efficiently. So after that one, we have to differentiate what is job scheduling and process scheduling and how they differ with each other. So first one is job scheduling. So job scheduling deals with managing a group of independent tasks or jobs that do not rely on each other. The scheduling of these jobs is typically based on priority, user, or the submission time. And decisions regarding the scheduling of these jobs are made before job execution. Examples of job scheduling is the first in, first out, or FIFO, the shortest job first, or SJF, and priority scheduling. On the other hand, we have the process scheduling. It manages processes created by the operating system, which so these processes may be interdependent and require communication with each other. The scheduling of processes is also typically based on priority, user, or a specific algorithm. Decisions regarding the scheduling of processes are made during the execution of the process. And examples of process scheduling algorithms includes the first come first serve or the FCFS, the shortest job next or the SJN, priority scheduling, the shortest remaining time (SRT), the round robin (RR), and multi-level queue or MLQ. So in summary for these two types of scheduling, while both job scheduling and process scheduling involve scheduling tasks or jobs, they differ in the nature of the tasks or jobs being scheduled. So for job scheduling, it deals with a group of interdependent jobs that do not rely on each other, while process scheduling manages interdependent processes created by the OS or the operating system. The scheduling decisions in job scheduling are made before job execution, while scheduling decisions in the process scheduling are made during process execution. So next reporter, please.
Okay, so now that we know what is the difference between the job scheduling and process scheduling, we will now proceed to what is a process scheduler. So, process scheduler is a component of the operating system that is responsible for selecting and allocating system resources to running processes. Its primary role is to manage the execution of multiple processes and ensure that they all receive a fair share of system resources such as CPU time, memory, and input-output devices. The process scheduler constantly monitors the system and decides which process to execute next based on specific scheduling policies or algorithms. It can also suspend, resume, or terminate process in response to various system events or user requests. In essence, the process scheduler is a key component that ensures optimal system performance and responsiveness by managing the execution of multiple processes in an efficient and fair manner. So this process scheduler is from is which that ang katong job na to kay ma-process na siya sa kanang CPU and it is waiting to be executed. So, next slide please. So, in our process scheduling, there are multiple policies or algorithms. So, what is process scheduling algorithm? Process scheduling is the activity of deciding which process should be performed first or when based on a particular strategy or algorithm. This activity is performed by the process manager as it removes an active process from the CPU and selects another from the queue. The need for scheduling in OS arises since most applications are multi-programming. In example, they allow for multiple process to be loaded and shared with the CPU at a point in time. The manager needs to make a decision on which of these process must be performed first. So there are three major process scheduler types as follows. The first is long-term job scheduler. Second is medium-term scheduler, and the last is short-term or CPU scheduler. So long-term job scheduler is the is also called the job scheduler. Long-term scheduler determines which programs are admitted to the system for processing. It selects process from the queue and loads them into memory for execution. Process loads into the memory for CPU scheduling. So this long-term scheduler is uh, siya katong ato ang katong mga job scheduling and so on. And next is the medium-term scheduler. Medium-term scheduler or medium-term scheduling is a part of swapping. It removes the process from the memory and it reduces the degree of multi-programming. The medium-term scheduler is in charge of handling the swap-out processes. So this will be further explained later. And last is the short-term or CPU scheduler. Its main objective is to increase system performance in accordance with the chosen set of criteria. It is the change of ready state to running state of the process. CPU scheduler selects a process among the processes that are ready to execute and allocates CPU to one of them. Short-term schedulers are also known as dispatchers, make the decision of which process to execute next. Short-term schedulers are faster than the long-term scheduler. So, next slide please. So, another component of process scheduling is the process queue. All programs and processes in the system are split up into queues as follows: job queue, ready queue, and device queue. So as you can see in the picture below is that we have first is that we have the job queue. So this job queue, this is all of the applications or processes that is waiting to be executed or waiting to be put in the process or the process scheduling or scheduler. So ang katong job scheduling na kuan mga algorithms like katong first in first out, priority scheduling, ma-apply na siya diri sa job queue. And once this application or process is ready to be processed sa koan ato ang system, it is put in the ready queue, which is waiting to be executed by the CPU and be terminated. So maaram na mo na ay exit dira. So makita nato diri there is a line above the CPU and bubalik siya sa ready queue. So this instance is when a process is executed in the CPU, but another process has a higher priority in the ready queue and must be executed first before our the initial process. So that ang katong higher priority will be executed first in the CPU, and ang katong daan nato nga koan nga process kay ma-swap out to siya and mabalik to siya sa ready queue na pod waiting to be executed sa CPU. So mao to siya ang palimurag mao na to siya ang ato ang midterm scheduler. Kay mama siya ang mag-handle sa kanang pag-swap sa ato ang process. Wait, I'm not done. So, napay usa din na makita nga line which is ang kaning padung siya sa input-output waiting queue. So, there is an instance nga ang kaning process nato kay ma-execute siya sa CPU. But ang kanang siya na process kay needed siya og kanang input-output devices. So, that process will be put into another queue na pod into the input-output waiting queue, which is it will wait for an available input-output device. And if that input-output device is available, it will be put in the input-output or to be executed in the input-output and be back to the ready queue for it to be executed na pod sa CPU and be terminated. So this is the basis, or this is mao ni siya ang kanang bale mo na kanang basis gani or basic nga process sa ato ang process scheduler or scheduling. So naatay mga criteria na needed for the process scheduler to meet for it to be a best or good algorithm. So we have here the criteria, which is first is the CPU utilization, next is the throughput, next is turnaround time, waiting time, and lastly, response time. So what is this CPU utilization? CPU utilization means that the scheduling algorithm should aim to keep the CPU busy for as much time as possible. So meaning our scheduling algorithm must have a degree of multi-programming. So as we can see, if we check our task manager sa ato ang system, kay makita nato na ato ang CPU kay maybe it is already occupied like 4%, 3%, 5% or 6% na depending. So ang kana na siya, mo na siya ang ato ang kanang CPU utilization, where ang CPU kay it is being used as much as possible because some processes must be executed at all times, but not like 100% jud ang atong CPU kay ma-use jud siya because dili na ta ka process sa ubang pang kinahanglan nato. So the schedule algorithm must utilize the CPU as much as possible, but not also nga 100% jud siya nga ma-utilize. So the next is throughput. Scheduling algorithm should aim to complete as many processes as possible in a given unit of time. So kaning throughput mura ni siya kanang for example, uh, 100 processes per second. So mo na siya ang ato ang throughput where the scheduling algorithm must aim to or must maximize the amount of processes it can complete in a given amount of time. So next is turnaround time. The total time taken by a process to arrive in a ready queue and complete. So ang kaning turnaround time, mano ni siya ang katong kani sa past na sa last picture na to. So ang mano ni siya ang time nga katong from ready queue to kanang waiting queue, and from waiting queue to CPU to be terminated or output. So the time it takes to uh, from ready queue to waiting queue to execution, kay it must minimize this time na moagi siya ay ngani sa mga queues. So dapat from ready queue, for example, ready queue kay paano siya 0.5 milliseconds, and sa waiting queue 0.1 milliseconds, sa CPU kay 0.3 milliseconds. So the total time na from that 0.5, 0.1, 0.3, 0.9 milliseconds, dapat yan ang i-minimize ang kana na siya na 0.9. So mo na ang ato ang turnaround time. Next is waiting time. Waiting time is the time that a process spends waiting in the ready queue before it is executed. So sa katong ready queue kay maghuwat na ang mga process kay maghuwat pa man jud siya na ma-execute kay napay usa ka process ka nagkuan nga nag-execute. So the scheduling algorithm must minimize this waiting time na ang katong mga process kay maghuwat. So dapat gamay ra ang time nga maghuwat ang process to be executed. And lastly, we have the response time. Response time is the time taken from the submission of the process until its first response is produced. So, ito yung mga instance, ito ang system kay pas-pas ra kaayo siya. Sorry for the sounds. So, natay instance nga ang ato ang system kay pas-pas ra kaayo siya nga mo process o process. So, that ang kaning turnaround time na to kay dili siya this ang turnaround time is not the best way to measure the efficiency of our scheduling algorithm. That's why we need the response time na it will measure the time that the process is being executed while ang katong output kay na kuan pa kanang naghuwat pa nga mo gawas. So by the time ang kanang output kay naghuwat pa siya mo gawas, kay ang katong another process is being executed na pud. So the time that it takes to first response kay mo na ato ang response time, o the schedule algorithm must minimize that response time. So next slide please. So here we have the categories of scheduling. There are two categories of scheduling. First is the non-preemptive and the preemptive. Non-preemptive means here the resource can be taken from a process until the process complete completes its execution. The switching of resources occurs when the running process terminates and moves to a waiting state. So, preemptive from ang mga resources kay the resources can't be used by another process uh, until this process is done executing or being terminated from the CPU. And the second is preemptive. Here, the OS allocates the resources to a process for a fixed amount of time. During resource allocation, the process switches from running state to ready state or from waiting state to ready state. This switching occurs as the CPU may give priority to other processes and replace process with higher priority with the running process. So, ang kaning preemptive kay manan to siya katong nag-swap-swap ta kay naay laing higher priority process. So, next slide. So, here we have the two-state process model. So, two-state process model refers to running and non-running states, which are described below. So, running or the running state means when a new process is created, it enters into the system as in the running state. So, when a new process is being created or being produced, kay mo ni siya ang kanana process kay it is now called a running state. Second is the not running. Processes that are not running are kept in queue, waiting for their turn to execute. Each entry in the queue is a pointer to a particular process. Queue is implemented by using linked list. Use of the dispatcher is as follows. When a process is interrupted, the process is transferred in a waiting queue. If the process is completed or aborted, the process is discarded. If in either case, the dispatcher then selects a process from queue to execute. So, this is so mo ni siya ang itong mga process scheduling policies and criterias. So now we proceed to process scheduling algorithms, which will be reported by another reporter.
So that was group 2.
Wala pa na human, sir. That's all.
Okay. Another reporter. Okay.
Hello, hello. Madungog ako.
Yes.
Okay. So, good morning everyone. I am going to discuss the first scheduling algorithm, which is the first come first serve scheduling. So, what is first come first serve scheduling algorithm? So, the FCFS in OS. The job that requests execution first gets the CPU allocated to it, then the second, and so on. So, from the name itself, it is easy to understand that the first come first serve scheduling means the process that requests the CPU first is allocated the CPU first. The CPU, and in the second process will be given the second chance, and so on. Then, characteristics of FCFS scheduling algorithm. So first, the algorithm is easy to understand and implement. Second, programs are executed on a first come first serve basis. And next is it is a non-preemptive scheduling algorithm. So that means non-preemptive, that means if a process gets to CPU, then all the other processes have to wait until and unless that process either completes its execution or waits for an IO. Then Next is, in this case, the ready queue acts as the first in, first out, first in, first out queue, where the job that gets ready for execution first also gets out first. Then lastly, this is used in most batch OS. Then so next is the advantages of first come first serve scheduling algorithm. So first is the fact that it is simple to implement means it can easily be integrated into a pre-existing system. And and next is it is especially useful when the process have a large burst time since there is no need for context switching. And third advantage is the absence of low or high priority preferences makes it fairer. And lastly, every process gets its chance to execute. Then there if there is advantages of first come first serve, there is also a disadvantages. So the first disadvantage is since it's first come since it's first come basis, small process with a very short execution time have to wait their turn. Thus, there is a high wait and turnaround time for this scheduling algorithm in OS. Although this is one of the simplest CPU scheduling algorithm, it suffers from the convoy effect. So, this occurs when multiple smaller processes get stuck behind a large process, which leads to an extremely high average wait time. This is similar to multiple cars stuck behind a slow-moving truck on a single road. And lastly, all in all, it leads to inefficient utilization of the CPU. So this this will not be a very good technique because let's say that we have so many processes which needs very less amount of time to complete, but at the head of the queue there is a big process that needs a big amount of time to complete. Then until and unless that big process complete its execution, all the other processes, though they may have a very less burst time, will have to wait. So if you are having a big processes, that means processes needing more time, then they are going to delay the entire processes that are waiting in the queue. So this is a disadvantage of this first come first serve scheduling algorithm. So let's go to the problem. So consider the set of five processes, those arrival time and burst time are given below. So we have a set of five processes whose processes IDs are P1, P2, P3, P5. So P1 to P5. And here it is given the arrival time. And here is given the burst time of these five processes. Now the question is to calculate the waiting time and average time for these five processes. So in order to solve this, first we all need to prepare the Gantt chart. So this is the Gantt chart. So basically what a Gantt chart does is that is that it will show you when did a particular process get the CPU for its execution and when did it complete its execution. So this is the Gantt chart. So here, if we analyze this table, we see that the process P3 arrived at time 0. So this was the first process to arrive. So we are following first come first serve scheduling algorithm. So the process that comes first must be served first. So P3 is the one that arrived first as it arrived at time 0. So P3 gets the CPU. So this one. So gets the CPU and it's doing its execution in the CPU. Now, how long does process P3 use the CPU? For that, we need to see the burst time of process P3. So the burst time of process P3, the burst time of process P3 is 3 units of time. So the process P3 will be executing for 3 units of time. So this is why we have shown this 3 over here. Kani, so man siya. So it arrived at time 0 and it got the CPU at exactly time 0 and it executed for 3 units of time. So here now, if you see here that we have a blank or shaded box, So the shaded box represents the idle time or of the CPU. So in order to find that we have to see the Gantt chart and this table and this table. So now if you look at this Gantt chart, we see that the third unit of time completed its execution. Now, if you look at this table, there are no processes that arrive at third unit of time. So wala siya, third unit so wala. So at the third unit of time, when P3 completed its execution, the CPU is idle. It is free and it was sitting idle. Nobody is using the CPU. So now if you look at this arrival time, what is the next arrival time that we have? So sunod sa sa 0, so arrival time sunod that we have is 4. 4 is the next biggest number just after 3. So okay, now let's see the process 1 arrive at time 4. And what is the burst time of P1? So P1 is 5 burst time niya. So 5 units of time. So P1 will execute for 5 units of time. So here, P1 got the CPU at the 4th unit of time. Got the CPU 4 unit of time. And it will executed for 5 units of time. Kay mao man yang burst time. So imo ra siya i-add. So 4 ni-arrive sa 4 unit of time and it will be executed for 5 units of time. So 4 plus 5 so 4 plus 4 plus 5 gives us 9. So the completion time of P1 is 9 unit of time. So once P1 completes, the next one to get the CPU is P5. So P5 got the CPU at the 9th unit of time when P1 completed its execution. Now, if you see what is the burst time of P5, it is 4 units of time. That is from the 9th unit of time, 9 unit of time, plus 4, which gives us 13. So, kanya siya 13, which is the completion time of P5. Now, what is the next process that arrive after P5? So we see that there is 6 and 6 here. That means both process P2 and P4 arrive at the 6th unit of time. Now the question arises, since they both have arrived at the same time, who will get the CPU? So in most of the system, what they follow is that when two processes arrive at the same time, kaning duha ka 6 dire arrive pareha man sila arrival time. So if pareha gyud sila kay, then the smaller process ID will first get the CPU. So manang P2. So how long it will be to execute P2? It will execute for 4 units of time. So ang burst time sa P2 is 4. So 13 plus 4 is 17. So P2 completes its execution at the 17th unit of time. So what is the next one? Obviously, it is P4 gets the CPU after P2 completes. Kay mao na may last then. And how long does P4 execute? So it execute so ang burst time sa P4 kay 2 units of time. So 17 plus 2 is 19. So P4 completes its execution in the 19th unit of time. Then next is so now our question was to find the average waiting time and average turnaround time. So we are going to calculate the average waiting time and turnaround time for this set of processes. Kani siya. Then, so this formula that we need to apply to calculate the average waiting time and turnaround time. So first, to calculate turnaround time is completion time. So para makalculate ang turnaround time, so completion time minus the burst time. Then to calculate the average of waiting time, turnaround time minus the burst time. Then sunod is, so now we have the formulas. Let's try to calculate. So here we have a table which we will calculate the required values. So we have the process ID kani siya P1 to P5, and here we have the completion time and turnaround time and waiting time. So the completion time kani siya can be easily seen from the Gantt chart. So ari ka tan-aw sa imong Gantt chart. So P1 is 9, so P1 completion time niya 9. So P2 17 kani siya, and P3 kay 3 niya. For P4 kay 19 mo ni siyang completion time niya, and P5 kay 13, so man siya. Then sunod is, so that is how we fill up this column for completion time. Tan-aw ra sa imong Gantt chart. Then sunod is we have to calculate the turnaround time. So to get turnaround time, tan-aw ra ka sa formula nimo. So completion time minus the arrival time. So what is the completion time of P1? So it is 9. So 9, then minus the arrival time. So arrival time of P1 is 4. So 9 minus 4 is equals to 5. Then sunod is P2. So completion time sa P2 is 17. Then ang arrival time sa P2 is 6. So 17 minus 6 equals 11. The next is P3. So P3 is ang completion time niya kay 3. So then minus the arrival time niya. So P3 arrival time, so 0. So 3 minus 0 so 3. Then next is P4. Completion time niya is 19. Then gi-minus sa iyahang arrival time na 6, so equals 13. Then sa P5, process P5 is 13 iyahang completion time minus the arrival time of 5 kani siya diri ari ra mo mo tan-aw. So equals 8. Then sunod, so we already found the turnaround time. So what is the waiting time? So giyon sa pagkuha ang waiting time. So waiting time, so turnaround time minus burst time. So mao ra na imong A minus. So ang turnaround time niya, so naa naman diri, so 5 minus the burst time. So P1 burst time kay 5, so equals 0. The next is P2, so 11 minus 4, so equals 7. So completion time niya is 11, arrival time burst time niya is 4, so 7. Then P3, completion time is 3 minus the burst time of 3, so equals 0. Then P4 is 13 yung turnaround time minus the 2 burst time, so equals 11. And then P5 is 8 yung turnaround time minus the burst time of 4, so equals 4. So we have calculated the turnaround times and the waiting times. So inanaan na siya pagkuha. Minus ra. So now we have the last step is to calculate the average turnaround time and waiting time. So it is easy, we already have the values here. So to get the average turnaround time, imo ra i-add ang values sa imong turnaround time. So 5 plus 11 plus 30 plus 3 plus 13 plus 8. So i-add nimo, so 40 nya imo ra divide of 5 because you have 5 processes. So divide mo 5, so i-plus 40 nya divide 5, so equals 8 units. So that's how you get the turnaround time. Then next is the waiting time. So same ra gyapon, so imo ra i-add imong value sa waiting time. So 0 plus 7 plus 0 plus 11 plus 4 nya 22 nya divide mo 5 kay nakay 5 ka processes, so 5, so equals 4.4 units. So that's how you get the average waiting time. So that's how we solve this problem for this first come first serve scheduling algorithm. So that's all. Thank you. Next reporter.
So next. So the next topic is the shortest job next, or also known as shortest job first scheduling algorithm. So the shortest job next, or also known as SGN, is a CPU scheduling algorithm that selects the shortest job on priority and executes them. The idea is that jobs with short burst time get done quickly, making CPU available for other longer jobs or process. In other words, this is the priority scheduling algorithm based on the shortest burst time or ang kanon ani niya kay ang kanang kinamab-an na oras. So, the next is the characteristic of SGF scheduling. So, ang SGF stands for shortest job first. So, this CPU scheduling algorithm has a minimum average wait time since it prioritizes jobs with the shortest burst time. Then, if the if there are multiple short jobs, it may lead to starvation. So, if there is a steady supply of short process, the long process may never get chance to be executed by the processor. There is a variety of scheduling algorithms proposed in the past to solve the issue of starvation in SGF. So the next is this is a non-preemptive scheduling algorithm. If the CPU cycle is allocated to any process, the process hold up the CPU until reaches a waiting state or it is to be terminated. So next is it is too easier to implement the SGF algorithm in batch OS. So the next page is the advantage and disadvantage of the SGM. So next page, please. So the advantage of SGF scheduling algorithm are it minimizes the average waiting time and turnaround time. So next is beneficial in a long-term scheduling. Then is better than the first come first serve scheduling algorithm. Useful for batch processes. So the next is the disadvantage of the SGF scheduling algorithm. As mentioned in a short-time job, if oncoming, it may lead to starvation for the longer job. So as a kator akong giingon ganiya na dili mag like iyang unahon ang katong mga gagmay na time. So it's dependent upon burst time, but it is not always possible to know the burst time beforehand. So does not work for interactive systems. Next. So here the first two processes of the executed as they come, but when the fifth process come in, it instantly jump to the front of the queue. Since it has the shortest burst time, the turnaround time and waiting time is calculated accordingly. It's visible that it is improvement of first come first serve as it is smaller average waiting time as well as smaller average turnaround time. So this algorithm is especially useful in cases where there are multiple incoming processes and their burst time is known as advanced. The average waiting time obtained as lower as compared to the first come first serve scheduling algorithm. So next report.
So another type of scheduling algorithm is the priority scheduling algorithm. This CPU scheduling algorithm in OS first executes the jobs with higher priority. That is, the job with the highest priority gets executed first, followed by the second prioritized jobs, and so on. So in short, we can say that they are sorted or organized based on the level of their importance. Now, the priority scheduling algorithm has its characteristics. So first, the jobs are scheduled on the basis of the priority level in descending order. Next, if a job with higher priority than one running currently comes on, CPU preempts, meaning stopped or paused the current job in favor of the one with higher priority. Next, but for other purposes, it follows a non-preemptive scheduling approach. So the priority scheduling algorithm can either be preemptive or non-preemptive. In between two jobs with the same priority, the FCFS, first come first served process, decides which jobs get executed first. And lastly, the priority of a process can be set depending on multiple factors like memory requirements, required CPU time, etc. Now, why do we actually use priority scheduling algorithm? Next slide, please. So these are the advantages of priority scheduling algorithm. First, this process is simpler than most other scheduling algorithms in OS. Second, priorities help in sorting the incoming processes. And lastly, works well for static and dynamic environments. The priority scheduling algorithm also has its drawbacks. First, it may lead to reservation problems in jobs with low priority. So again, a reservation problem refers to a situation where a process with a low priority level does not get a chance to execute for a long time, or perhaps never gets to execute at all, despite being in the queue. Secondly, the average turnaround and waiting time might be higher in comparison to other CPU scheduling algorithms. So, next slide. So this is an example of priority scheduling algorithm in OS. Here, different priorities are assigned to the incoming processes. So in our case, if we look at the table, we have five processes at hand. We assume that these processes arrive at the same time, considering the arrival time was not given. So this might be slightly different process compared to the one that has arrival time or given arrival time. So as you can see in the table, we only have the process ID, burst time, priority number, waiting time, and turnaround time. So the first process, P1, has priority number of 3. When we look at the next process, P2, the priority number is 1. Now, there are instances where the higher the value, the lower the priority. But in this example, our condition is the lower the number, the higher the priority. So if we look at the priority column, 1 is the lowest value, therefore having highest priority among others, and 5 having the lowest priority. So in the execution, P2 is executed first because of priority 1, followed by P5, P1, P3, and P4. So priority number 1, 2, 3, 4, 5 in order. So because P2 is first to be executed, it will have a waiting time of 0 with turnaround time of 1 because it has burst time of 1. So 0 plus 1 is 1. The next process to be executed will be P5 since it has priority number of 2. When we look at P5, it has waiting time of 1 since P1 or the previous executed process takes 1 unit to complete its execution with turnaround time of 6 because P5, when we look at P5, it has a burst time of 5. So waiting time plus burst time, 1 plus 5 is equal to 6. The next execution is with priority number 3, P1. P1's waiting time or P1 enters at time 6. So 6 is the amount of time the previous process takes to finish execution with turnaround time of 16 because of its burst time of 10. So waiting time plus burst time, 6 plus 10 is equal to 16, and so on with the remaining process. So in this example, the average waiting time is the sum of all values in waiting time column divided by the number of processes. That equates to 8.2, and the average turnaround time is 12. Now this is known as priority scheduling. The calculated times may not be the lowest, but it helps to prioritize important processes over others. And that would conclude the priority scheduling algorithm.
So next, scheduling algorithm is the shortest remaining time first, or the SRTF. So the SRTF scheduling algorithm is the preemptive version of the SJF. So SJF is a non-preemptive scheduling algorithm. So in operating system. So this calls for the job with the shortest burst time remaining to be executed first.
and it keeps preempting jobs on the basis of burst time remaining in ascending order. So again, preemptive means that the operating system can stop or interrupt a running process before it completes the execution. So preemptive scheduling, it allows the operating system to interrupt the currently executing process and allocate the CPU to another process with a higher priority. So characteristics of the SRTF scheduling algorithm. So the incoming processes are sorted on the basis of their CPU burst time. Second, it requires the least burst time to be executed first, but if another process arrives that has an even lesser burst time, then the former process will get preempted for the latter. So, for example, ang kaning currently process is kanang nanay bag-o ni arrive nga process nya mas less iyang burst times kaysa sa katong currently nga ni run nga process. So, ang katong currently run mo process, mo stop to siya, mo interrupt, o katong new na arrive nga mas lesser ang burst time, mao to siya ang mo execute. Then next is the follow of execution is a process is executed for some specific unit of time. And then the scheduler checks if any new processes with even shorter burst time have arrived. So the SRTF, it schedules the processes based sa ilahang burst time. So where the processes with the shortest remaining burst time is selected next. So if a new process arrives nga mas less ang iyahang remaining burst time is mao to siya ang mo currently execute nga process. So ang kaning burst time mao ni siya ang amount of time that a process requires to complete its execution on the CPU. So next slide please. So the advantages of SRTF scheduling algorithm. So first is more efficient than SJF since it's preemptive version of SJF. So mas efficient daw siya sa shortest job first nga scheduling algorithm since maka-preempt ang kaning running process and maka-allocate ang CPU time to a process with an even shorter remaining burst time. So it can lead to a more optimal scheduling of processes. So next is efficient scheduling for batch processes. So ang SRTF is particularly efficient for batch processes. Is this where the system is required to execute a large number of jobs. So this is because SRTF scheduling process based on the remaining burst time. And next is the average waiting time is lower in comparison to many other scheduling algorithm and operating system. So the lower average waiting time in SRTF has many scheduling algorithms and operating system. This is because SRTF always selects the process with the shortest remaining burst time. So it can ensure that the process spends less time waiting in the ready queue. And next is the disadvantages of SRTF scheduling algorithm. So longer processes may starve if short job keeps getting the first shot. So ang SRTF can cause longer processes. This happens because the scheduler gives priority to the process with a short remaining burst time. So daghan ang mga preemption. So daghan ang mga interruptions between sa processes. So which might have to wait a long time before they get a chance to execute. And next is can't be implemented in interactive system. So ang kaning SRTF is not suitable for interactive system because the process with the shortest remaining burst time is given a priority, which might result in longer processes being blocked, leading to slower response time. And next is the context switch happens too many times, leading to a rise in the overall completion time. So daghan og mga context switch or naay mga daghan og mga preemption nga mahitabo ani because of i-consider ang burst time sa each processes. And also lastly, the remaining burst time might not always be apparent before the execution. Next slide, please. So in this figure, in example, we have the process A, B, C, D, E, and their arrival time, their service time or their burst time, then waiting time, and the turnaround time. So here, the first processes starts first and the second processes execute for 1 unit of time. So note ni siya important na if wala pa gani na arrive ang tanan process, it is better nga mas mogamit ta og 1 unit of time sa ato ang process. Kay para mas ma-take note na to kung unsa ang mga processes ang ni-arrive and mas dali na to mabantayan ang each processes. Like for example, sa process A, so arrival time niya is 0. So first, mo siya una ang atong i-process sa atong Gantt chart. So, iyang service time, ay iyang burst time is 3. So, hantod siya sa 3. And then, namta sa 3, then arrival time na amay sa si B, iyang burst, arrival time niya is 2 niya. Atong nanamta sa atong 3, sa atong burst time. So, i-consider nato kung kinsa ang process ang less og ang burst time. So, since ang process A mas less mag service time, so ipadayon nato siya hantod sa 3. Hantod, makomplete na siya and i-terminate na nato siya sa process. And so on and so forth sa uban. So, to calculate the, so ang kaning completion time is, ang pagkuha ng completion time is kung kanus ato ang kanang process ni complete sa atong Gantt chart. So, sa waiting time, makuha ni nato siya through complete time minus the arrival time, then minus the burst time. And ang kaning waiting time is, kuha ni siya burst time, ay turnaround time, mao ni siya ang burst time plus waiting time. O pwede sa nato apilan og response time. Ang response time, mao ni siya ang kanang mag-take note sa start time of execution sa each processes. And also, if nanatay mga values diha sa atong waiting time, turnaround time, pwede naton makuha ang average waiting time o average turnaround time sa atong processes. And next slide, please. So next, scheduling algorithm is the round-robin scheduling algorithm. So in this scheduling algorithm, the operating system defines a quantum time. So ang quantum time, mao ni siya ang fixed time interval or slice of time allocated sa process for execution in the CPU. For example, sa round-robin scheduling, each process is given a quantum time and mo-run siya for that duration of time, and if mahuman na ganin siya ang kanang duration time nga gihatag, pwede na siya ma-preempt ang kanang process considering kung kinsa to ang mas lesser og burst time. And katong if wala pa gani na human ang kana nga process, pwede na siya ibalik nato sa ready queue. And every job is run cyclically for this predefined period of time before being preempted for the next job in the ready queue. The job which are preempted before completion go back to the ready queue to wait their turn. So it is also referred to as preemptive version of the first come first serve scheduling algorithm and operating system. So the characteristics of the round robin scheduling algorithm, first is this is a once a job begins running, it is executed for predetermined time and gets preempted after the time quantum is over. So ang kanina siya nga process, if ang process nag-run, so mag-agad siya sa gihatag nga quantum time sa duration kung kanus siya mo stop. Pero if ever gani ang burst time niya mas lesser siya sa quantum time, pwede ra siya dili na mag-agad sa quantum time and ma-complete na siya before siya mo ato sa makuha niya ang katong duration time nga gihatag. So next is, it is easy and simple to use or implement. Next is the RR scheduling algorithm is one of the most commonly used CPU scheduling algorithms in operating system. Also, it is a preemptive algorithm system. Next slide. So as we can see in the figure, so we can see the rectangular blocks represents the processes that are waiting to be executed. Each block has like for example, let's label it as P1, P2, and P3. So the circular block in the center of the figure represents the CPU. The process that is currently executing on the CPU is indicated by the pink block inside the circular block. So ang kaning block that are connected sa CPU, mo ni siya ni-represent sa atong time quantum or quantum time and assigned to each processes. So in this example, the time quantum is 3. So each processes gets 4 gets 4 time units of CPU. So the time before it is preempted and moved to the end of ready queue. So the blocks on the right side, mao ni siya ang figure nga represents sa amount of time that each processes has spent executing some CPU. So as each processes is selected to run on the CPU, its timer is reset to 0 and it starts counting up to the process executes. So if a process is preempt gani siya before, so wala pa siya na complete, then mo balik siya ato sa ready queue. And so that it can be resumed from where it is left off and when it gets another turn on the CPU. So next slide, please. So the advantage of RR scheduling algorithm. So this seems like a fair algorithm since all jobs get equal time. So kaning round robin is makuha siya equal siya nga process since ang tanan process tagaan siya og equal nga quantum time para maka-process. And next is does not lead to any starvation problems. And next is new jobs are added at the end of the ready queue and do not interrupt the ongoing process. So unlike sa katong short remaining time nga maka-interrupt siya basig pila ka unit ang kuan, unlike kaning sa RR is mas wala di siya maka-interrupt until katong kuan na ang duration sa time quantum. And next is leads to efficient utilization of the CPU. So also there's a disadvantage of RR scheduling algorithms is every time job runs the course of quantum time, a context switch happens. So this adds to the overhead time and ultimately the overall execution time. So next is a low slicing time may lead to low CPU output. And next is the important tasks aren't given opportunity. So since equal naman siya og quantum time, ang katong mga bugat nga task or mga large nga task nga dapat unahon or priority is dili siya ma-prioritize since equal man ilahang kuan ilang quantum time nga ihatag sa processes. And lastly is that choosing the correct time quantum is a difficult job. So ang paghatag sa quantum is lisod sad siya is kay diha magbase kung pila ay unsay duration time sa imong processes. And next slide please. So as you can see in the figure again, we have the processes A, B, C, D, E, arrival time, its burst time or service time, and their waiting time and their turnaround time. So let's take a quantum time of 4 units. So the first processes will execute and get completed. So after the gap of 1 unit, the second process executes for 4 units. Then the third one executes since it has also arrived in the ready queue. So after 4 units, the 4 processes executes the process, keeps going until all processes are done. So it is worth noting that the minimum average waiting time is higher than some of the other algorithms. So while this approach does result in a higher turnaround time, it is more efficient in multitasking environments in comparison to most other scheduling algorithms. So ang kaning process scheduling, like for example, ang arrival time sa process A is 0. So una siya. So since naaman tayo gihatag nga quantum time nga 4 units, so pwede siya mo hantod sa 4 4 units nga time. So since 3 raman iyang burst time, so before siya mo makakuan sa katong 4 units, dito siya kutob sa 3 since iyang burst time nga need is 3 raman. So after ana is ma-terminate na siya and kay na-complete na siya. And next is ang sa arrival time sa katong 2 gani since na naman ta sa 3 nato nga unit ay 3 nga unit, since ang katong arrival time sa B is 2 man, so ibutang nato siya sa ready queue. So and after, since na-complete naman ang process A, pwede ang after ana is ang katong naa sa ready queue since naaman ang process B, mo na to siya ang atong next nga i-process. Since 4 man atong quantum time, then ang burst time sa process B is 6 man, so kutob rata sa kuan since 3 dayon 9, so 9 rata ay no 3 ay 7 rata kutob. Then after ana, since napamay nabilin nga burst time ang process B nga 2, so ibalik na to siya sa ato ang ready queue. But before nato siya ibutang, since naamantay nanamta sa 7 nga unit time, then ang process C o process D is ilahang arrival time is 4 and 6. So before nato ibutang ang process B, ibutang sa nato si process C since 4 iyang arrival time and si process D kay 6 iyang arrival time. So ang kani siya is ma-implement sa nato ang first come first serve. So ang first na process is ang katumang C since arrival time niya is 4. Then after ato nga mo process ka sa atong process B, then sa ready queue na anay C, D o katong B nga katong nabilin nga 2. So after anang B is ato nakabalik sa C since siya man ang katong naa sa ready queue nga pinakauna. Then after mao na siya ang hantod mahuman na nimo ang process tanan. So ang kani the same ra sa katong kuanang process, ang pagkuha sa waiting time is mao ni siya ang complete time or completion time minus burst time minus arrival time. And sa katong turnaround time, mo ni siya ang waiting time plus burst time. Then after makuha nimo sa value sa waiting time and turnaround time, diha na nimo siya i-add and kuhaon nimo ang average each time. And that's all.
So, multiple level queue scheduling algorithm, or in short MLQ. The multiple level queue scheduling approach calls for the first dividing of all the processes in the ready queue into different classes on basis of their scheduling needs. This lead to the creation of multiple queues. For example, queues of foreground jobs, batch jobs, etc. The OS then treats these queues individually and executes them by running different algorithms in them. Take a look at the diagram below. So we have here the jobs with common characteristics are grouped into individual queues. Each queue is assigned a scheduling algorithm depending on specific needs. The queues are then given a priority level to decide which queue gets CPU time first. So summarized of all is there are certain and different conditions. Each characteristics are implied sa scheduling algorithm sa multiple level queue. So next. So this is the three parts of a multi-level queue. So the first one is system processes, which is defined as highest priority, the medium priority is interactive processes, and the lowest priority is the batch processes. The figure above displays how processes are separated on the basis of their priority depending on the type and executed using different algorithms. Here, for example, the first come first serve, as we discussed later, the SJF and the round robin schedule algorithms. So ang example sa system processes is the memory management processes. It's happening entirely or mainly in the surface of the processing unit, CPU, and the task scheduling processes, the input and output system processes, and of course the security management processes. And for the interactive processes, which is the medium priority, we have here the web browsers and text editors, media players, communication applications, such as like messengers, Discord, Telegrams, and any application or software that can provide communications. And of course, the graphical user interface. And the last one is the lowest priority, batch processes. Batch processes are those that do not require user interaction. So it doesn't need any interaction anymore, and they're processed in bulk or in a big batches. These processes are usually placed in lower priority queues in an MLQ system to avoid interfering with higher priority processes. So, ang mga example ani is, for example, the large file transfers, backing up files, restoring files, regeneration of files, and software updates. So software updates such as anything that likes that will receive the lowest priority in terms of processing. So next. So there are two types of getting the MLQ system. There are two types of advantages, and of course it has more too sa disadvantages. So sa advantages is it uses a combination of algorithms to provide the best results. So which is way more important and heavier, of course. May anahon, and then the overhead time is less. So ang iyahang complexion of queuing is fixed. When it's the highest priority, it's the highest priority. So, and disadvantages of MLQ is once a job is assigned to a queue, it cannot be changed. This may lead to inflexibility and hence inefficiency. So we all know na once it is assigned already, it cannot be changed. The queue cannot be changed. So if ang system process sa MLQ kay whether na ang iyahang category kay nabilong sa for example medium, I mean the interactive processes, or sa katong second highest priority is if we want that to do first, we really can apply, or we really can do that for ang process sa MLQ kay of course the highest priority, second, and the lowest. This may lead to a starvation problem if high priority queues does not allow for low priority queues to take turns, and that's what have discussed kanina about starvation problem. If ang high priority queue does not allow for priority queue to take turns. Not easy to implement, of course. Ang MLQ processes kay whether you want something, or in a process or batch processes nga mo take over to another nya gusto nimo i-replace some processes, it could happen, but entirely not the best, or not what we call this, na it's not something to be applicable in easy way. So, and the last one is sorting the jobs might become complex. So since it's already fixed, the queuing is fixed, so it's there and cannot really entirely be changed, but at some sort of situation or aspects it could. So that's all. I guess next slide. Yeah.
So that is all for the